Hey, you guys, it's Miss All Day. How are you guys doing? It is Friday, May 8th, and this is your second to last new lesson. So we're going to get started. This is 8-5. We're going to do part A today, and then we'll do part B on Monday. Okay? All right, so let's get started. So adding and subtracting rational expressions. Remember, rational has the root word ratio, so we're talking about fractions. Okay? All right, we're going to start out with finding the least common multiple of the given expressions. Now remember, least common multiple, that's going to be a number that both 18 and 12 can go into evenly, and it's going to be the lowest number. So there's several ways you could do this. You could count by 18 and you could count by 12, and then you could see where they have one in common. But I want you to just think about it and see what you think it would be. All right, so basically the easiest thing to do is start with the larger number and say, okay, well, 18 times 1, of course, is 18. You know 12 can't go into 18. All right, so let's see 18 times 2. What is that? 36, right? Can 12 go into 36? All right, then that's going to be your least common multiple. That's your LCM. Because 18 and 12 can both go into it evenly, and it's the smallest number that they both can go into evenly. All right, so let's start with a big number here, 20. Well, we know 16 can't go into 20, so 20 times 2 is 40. Well, 16 can't go into 40. Well, 20 times 3 is 60. Well, 16 can't go into 60. All right, well, 20 times 4 is 80. 16 can go into 80. All right, so your least common multiple is going to be 80. Now, when you're given variables, what you want to do is you want to circle the one that has the highest exponent. Okay? Can you divide x into x squared? You can. So that's going to be your least common multiple for the variable x. All right, now let's look at the variable y. The biggest exponent is y to the third. Can you divide y into y to the third? Yes. So the LCM of those two expressions is going to be 80x squared y cubed. Now looking at the next one, you're like, okay, I got this. 15 can go into 30, so we know it's going to be 30. All right, so your LCM is going to be 30. Now find that one with the biggest exponent and see, does the other one have at least one a? Okay, then you're going to use a to the fourth. All right, next, there's only one b used in each one, so that's what you're going to use. You're going to just use 1b. So this is c cubed, but this has c squared in it. So as long as one has a c and the other has a c, you choose the one that has the biggest exponent. So there's your least common multiple. 30a to the fourth b c cubed. All right, now to add or subtract fractions, the reason why we practice least common multiple is you have to have a least common denominator, okay? The common denominator is the least common multiple of the two denominators. Now, once you have a common denominator, you add and subtract the numerators, and you keep the denominator the same, and then you reduce or simplify if you can. All right, so let's start with this first one. All right, we see that they have the same denominator. So this is just going to be 5 minus, I'm going to trace over that minus sign. Some people like to put plus negative. It doesn't matter. You're still going to get 3 over 18. Now divide them both by 3, and you'll get 1 over 6. That is the difference between those two fractions. 5/18 minus 2/18 is 1/6. All right, let's go to B. If you're looking at those, they have the same common denominator as well. So there's a plus sign in between. So let's add the 7 and the 3 first because they're constants. That'll be 10. And then 1v and negative 3v is going to be negative 2v. All right, and that's all going to be over 8v. Now, the next thing you want to do, because if you notice, the 10, the 2, and the 8, you can divide them all by 2. What we're going to do is we're going to pull out the GCF of 2 in the numerator. So we're going to pull out a 2. 2 times what is 10? 5. 2 times what is negative 2v? Negative v. And this is all over 8v. All right, we're going to cancel the 2 with the 8. So 2 goes into 2 one time, and 2 goes into 8 4 times. All right, so our final answer for this is going to be 5 minus v over 4v. Now remember, like I said the other day, you can put this in parentheses if you want to. You don't have to, as long as you realize that those go hand in hand. You cannot do any more canceling. That is your answer. All right, let's look at C. I see that the common denominator is 6m cubed n and 6m cubed n. So they have common denominators. Now, you see that minus sign in between? You must take that minus sign and distribute it. Okay, so I'm going to just pull up the minus sign and we're going to distribute it first. So I'm going to rewrite m minus 3n, and I'm going to put it all over 6m cubed n plus, and I'm going to distribute the negative, negative m minus 3n all over 6m cubed n. All right, we have m minus m. Well, that just disappeared. All right, and we have negative 3n plus negative 3n, and that's going to give us negative 6n over 6m cubed n. Now, we have some canceling to do, because on this one, there is a minus sign in between them. If you have a minus or a plus sign in between two expressions, you can't cancel. But here, there is not a minus or plus sign in between two expressions. So what we can do is we can cancel the 6's, we can cancel the n's, but remember, I always said there's still a 1 up there. So that's going to be negative 1 over m cubed. All right, let's look at D. It has a common denominator. We're going to take this negative sign here and we're going to distribute it. So I'm going to make this a negative and this a negative. And then I'm going to go back to that negative sign in the middle. And since I distribute it, I'm going to change it to a plus sign. That kind of saves us from having to rewrite. All right, let's look at 2x minus 1x is going to be x. And then negative 1 minus 5 is going to be negative 6. And that's going to be over x minus 2. We're done. Now remember, if you want to put these like this so you don't cancel them, you can, but you don't have to. That's your answer, x minus 6 over x minus 2. All right, for this next one, we don't have any like terms to add the n to, but we have negative 2 plus 6, which is going to give us 4. It's going to give us a positive 4. Okay, now we're going to take the denominator of both of them and we're going to factor it out. Okay, because they have a common denominator, but we have to see if we could cancel anymore. So we know that n times n is n squared, and that 5 times 4 is 20. And if I have a negative 5 and a positive 4, then that will end up being the negative n in the middle. All right, so now, remember, this is really in parentheses. We can cancel those two, but remember, there's still a 1 left up there, okay? So we have 1 over n minus 5. And that's our answer for that one. All right, now for this next one, there is not a common denominator. And I don't like to do fractions or solve fractions horizontally. I like to do them vertically. So let's count by 15 and see what number 9 can go into. We know 15 times 2 is 30, and we know 9 can't go into 30. So 15 times 3 is 45, and I know for sure that 9 can go into 45. So we're going to rewrite it like this. 4/9 minus 7/15. And we're going to set them equal to, and we're going to let our common denominator be 45. So I'm going to refresh your memory on how to do fractions, just because it's usually most math students' least favorite thing to do. So you ask yourself, 9 times what is 45? So it's 5. So if you multiply the denominator by 5, you multiply the numerator by 5. So it's going to be 20. All right, 15 times 3 is 45. So you're going to multiply 7 times 3. But don't forget there's a negative out here. So go ahead and put minus 21. Now you know that's going to be a negative 1, right? Because when you combine 20 minus 21, you subtract and you take the sign in front of the number with the greatest absolute value. So we're going to have negative 1/45. All right, let's look at G. We have 3 more we're going to do for this lesson. Now we can already tell that these do not have a common denominator. So I like writing it like this vertically. 2 over 3a squared b plus 1 over 5ab. Now remember when we were doing the least common multiple up at the top of the page, we were choosing the one that had the most a's. It had the highest exponent. So we know for sure already that we're going to use a squared for both of them. All right, and they both have one b, so we know we're going to use a b. Now, if you look at 3 and 5, they're both prime numbers, so multiply them and you'll get what they both go into. They both go into 15. All right, so that's our least common multiple or our least common denominator, same thing. All right, so now what do I have to multiply this 5 by down here to get 15? All right, that's going to be 3. So we're going to multiply it by 3. I think I'll just put parentheses since I don't have a lot of room there. I'm going to multiply it by 3. All right, and then I have 2 a's right here, and I need to multiply a times a to get those 2 a's. But I don't have to multiply b by anything. All right, so if you multiplied 5ab times 3a, you will get 15a squared b, which is what we wanted. Okay, so you multiply the denominator by that. Now you're going to multiply the numerator by that. So you're going to get 3a. All right, now 3 times what is 15? That'll be 5. There's an a squared on the right there. There's an a squared on the left. There's a b on the right. There's a b on the left. So you don't have to multiply by anything else except that 5. Because if you take 3a squared b and you multiply it by 5, you'll get 15a squared b, and that's what our common denominator is. All right, so now we've got to multiply the numerator times 5, so that's going to be 10. Now remember, these are both being added, so if you need to put the plus sign in front of the 3a to help you remember that, that's fine. All right, so I'm going to do 3a plus 10 instead of 10 plus 3a because I like my variables to go in front. And this is going to be over 15a squared b. And 3, 10, and 15 do not all share a common factor. So that is our final answer right there. All right, let's look at H. I'm going to put n over 6m. And I'm going to put m plus 2n over 15m. All right, draw a line. We're adding these. All right, so I'm going to count by 15, and when I say 15 times 2, 30, I automatically know that 6 and 15 both go into 30. So I'm going to put 30 as my least common denominator. They both have an m, and so I only need one. I take the variable with the highest exponent. All right, so what did I have to multiply the denominator by for 15m? I'm going to have to multiply it by 2. So now I'm going to have to multiply the m plus 2n by 2. So 2 times m is 2m, and 2 times 2n is positive 4n. All right, 6m times what is 30m? That's going to be 5. So multiply the numerator times 5. All right, so now we're just going to put them in order. So I'm going to do order, meaning m comes first, so 2m, and then 4n, n comes after m. Oh, I have a 5n and a 4n. Okay, so I'm going to add those together. Sorry about that. I have like terms. So that's going to be 9. I was thinking I had a constant for some reason. All right, so 2m plus 9n divided by 30m. And there's nothing that all three of them share, so I'm not going to be able to bring anything out to factor it and reduce more, just like the one before. They had no common factors. Excuse me. All right, last one for today. We have 3 plus x over 6x minus. Now I'm going to take this minus and go ahead and distribute it, okay? So it's going to be negative x plus 5 over 3x squared. All right, I'm going to put equals. I'm going to put our fraction bar. I'm going to change colors. All right, now we know that 3 and 6 both go into 6. And we know the variable that has the highest exponent is x squared. So we're going to use x squared. All right, now for the bottom one, we'll start with it. 3 times what is 6? So we know that's going to be a 2. I'm going to change it to a different color. 2. And then x squared times 1 is x squared, so I only have to multiply it by 2. So I'm going to have to multiply the numerator by 2. So 2 times negative 1x is negative 2x. And 2 times 5 is 10. All right, what do I have to multiply 6 by to get 6? 1. What do I have to multiply x by to get x squared? We're going to multiply x. All right, so we're going to have to multiply the numerator times x. And you see that when I'm multiplying the numerators by either a constant or a variable, or it could have been a constant and a variable together, I have to put parentheses around them and distribute it. So x times 3 is 3x, and x times x is x squared. All right, I'm going to take the x squared and I'm going to put it first. And then we have 3x minus 2x, and that will give me 1x, but I'm just going to write x. And then we have plus 10, and that's all over 6x squared. Now, normally I would try to factor out the x squared plus x plus 10, but I know there's not two numbers that when multiplied, I'll get 10, and when combined, I'll get 1. So I know it can't factor anymore. So that is my answer. All right, so that concludes 8-5, day 1, or part A, whatever you want to call it, adding and subtracting rational expressions with common denominators. All right, so your homework is going to be the 8.5A worksheet, okay? And check your answers. I'll try to have those up by the end of the day, or they may be already up now. I'll try to have it up by the end of the day so you can check your answers and make sure you got that concept. All right? So I hope you have a good weekend, and I'll see you on Monday with our last new lesson. All right. Thank you, guys. Bye.